Welcome to attend Alibaba Cloud training. I'm Dean, a teacher from Alibaba Cloud Corporation. In this training, we will talk about how to operate and manage a cloud server. Here are the objectives of this course. After taking this course, you will learn how to get your own cloud server on Alibaba Cloud. You will learn how to manage this cloud server efficiently, how to deal common operational tasks. You should also learn how to prevent problems that may arise from your cloud server. Here is the contents of this training. We will first talk about the 3 reasons to embrace cloud server. Then we will move to how to provisioning a customized ECS instance. This is very simple. It only takes 1 minute to submit an instance creation job. Next, we will talk about how to manage ECS instance using ECS Web Console. In the final session, we will see how to operate an ECS instance. Okay, first, let's talk about the 3 reasons to embrace cloud server. So, what is ECS? ECS is a key product of Alibaba Cloud. ECS is a computing service with flexible processing capacity. Compared to physical server, ECS can easily deploy and manage applications with better stability and high efficiency. Its flexibility can also lower overall IT cost, enable you to focus on key business innovations. Let's compare the physical server with ECS instance. When you use physical server, you need to first purchase the hardware and then find a data center for it. If VPN is needed, you also need to buy VPN service. You also need to pay for the hardware upgrade to meet your new business requirement after a period of use. To operate and manage the physical server, you need to hire professional operational engineers. These tasks require a lot of time and money. It may cause your application release delay if any unexpected issue in this list occur. With ECS, it will change the way to set up a server which fits almost all the requirements you can imagine. What you just need to do is register an Alibaba Cloud account and one click to provisioning your server. Operate and manage for this server can be done easily through the Web UI console, even for a junior engineer. ECS also provides security features to protect your server from any attack. So yes, ECS is a better option than physical server. Next, let's look at more details about ECS features and why you should use ECS rather than physical server. Easily deploy and manage is definitely the first reason to choose ECS. Alibaba Cloud provides a Web UI console to manage your ECS instance. For example, you can provision a new cloud server by a few clicks. You can easily change the server type, such as CPU, memory, network bandwidth, to upgrade your server by a few clicks too. With ECS, no operational is needed anymore. Almost all maintenance and daily operations for cloud server can be done from the console. You just need to log into the console and choose the operation you need and submit. Then that's it. Everything is done for you. Another thing is the support policy. Alibaba Cloud provides 7 days, 24 hours support. You can get professional support at any time you need it. Another reason to choose ECS instance is the better stability and high efficiency. Let's take a look at some failure case and how ECS deals differently from the traditional server. If server failure occur, since ECS use virtualized server cluster, is able to migrate to another available server automatically. For disk failure, in a traditional server case, if you don't set up disk backup, it may cause data loss. and not be able to recover. ECS uses distributed file system with 3 redundant copies for all data. You don't need to consider data backup by yourself. Traditional server may also encounter server room power outage situation. For ECS, Alibaba Cloud has set up the power redundancy backup for all the ECS server. ECS is also enabled the basic DDoS protection by default for your instance, and the important thing is that it's free. ECS instance provides 99.5% service availability and 99%, almost 100% data reliability. It definitely provides better stability and high efficiency than traditional server. The last reason is the cost. The following table gives a rough evaluation about the cost for ECS instance at traditional IDC. For example, according to the application and workload requirement, you need a server which have 8-core CPU, 24 GB memory, and 1 TB hard disk. First, about the hardware cost. ECS cost is about $3,900 per year. $3,900 per year. Sorry. For traditional IDC, one-time procurement for the package is about $3,000. Let's assume hardware is depreciated by 5 years, so the annual cost is about $600. About server room trusteeship, no extra cost is needed for ECS because this is covered by service provider. Traditional IDC needs about $1,200. About bandwidth, network bandwidth, let's assume 5 MB is needed. The cost for ECS is $157. For traditional IDC, it's much higher than the ECS. For operational engineer cost, today monthly salary of a junior operational engineer is at least $800. Consider the social insurance. The cost for the company should be about $1,000. Assume the current project will occupy 10% workload of this engineer. The cost should be $1,200 per year. In ECS case, ECS provides a web UI console for you to perform the most common operational tasks easily. So no operational engineer is needed. After a quick math, the total cost for ECS is $4,150. While the cost for traditional IDC is $6,600. You can see the cost is significantly reduced if using ECS. Elastic Compute Service is a computing service with flexible processing capacity. Compared to physical server, it has a lot of advantage. So ECS can easily deploy and manage applications with better stability and high efficiency. Its flexibility can also lower overall IT cost, enable you to focus on key business innovation. Okay, that's all for this chapter. Thank you very much for watching. See you later. Welcome back to Alibaba Cloud Training. In this section, we will talk about the provisioning of a customized ECS instance. You will see how simple to create a new ECS instance is. Here is a quick question. Let's guess how many steps to provisioning a ECS instance. Actually, the answer is 3. First, you need to register an Alibaba Cloud account and add a verified payment method. After that, you can create your own ECS instance according to your requirement. You have various choice for the CPU, memory, bandwidth. And the creation method will also provide you recommended configuration by default. Once you input all required information in the method, click Submit. That's all. Instance will be available in 3 minutes. Here is our official website and console. Users can access alibabacloud.com to register a cloud account. After adding a verified payment method, you can start to create your own ECS instance. Before we go to the demo, I need to introduce some concepts about ECS. Instance. An ECS instance is a virtual computing environment including CPU, memory, and other fundamental computing components. Regions and zone. The geographical area region refers to the city where Alibaba Cloud provides the cloud computing service. Zone refers to, within a region, the physical data center. Disk. Disk is used to store system and user data. It can be scaled up at any time. So what is a disk image? Disk image is the template of a runtime environment for ECS instance, including OS, pre-installed software, and related configurations. What is VPC? VPC is a virtual network in your own logically isolated area within the Alibaba Cloud. It provides VLAN level isolation and blocks outer network communications. What is security group? Security group achieves isolation between different security domains inside VPC. This fits the internal network management needs of applications in government or enterprise. Okay, let's start the demo. It's about how to provisioning a customized ECS instance. First, I will open my Chrome, and here is our official website, alibabacloud.com. In this website, if you don't have a cloud account, you can click free account here and register a new account. After you add a valid payment, you will get 300 coupons in your account. You can use it to create your own ECS instance. So I already have an account, so I will log in directly. Here, input the email address and input the password. Okay, input the verification code and click the sign in. Okay, this is the page after you sign in, and here we will create click console here to access the web console. From here, because we will create a new ECS instance, so click ECS server here and click instance. In here you can choose the regions and zones. We will use default zone Singapore, and then create instance button. Okay, here is the create instance method. First you need to choose a pricing model. There's two pricing model here, subscription and pay as you go. For pay as you go, you will only build for the exact value you actually used. And subscription will provide you with discount compared to pay-go instance pricing, but it's available in either monthly or yearly subscription. Here we will use pay as you go. Okay. Now data center and region, we will use Singapore, Zone B. And next, instance type, we will use the smallest one for the string, 1 CPU core, 2 GB memory. The network type page, we can choose the default value for VPC, and for the switch security group, I will choose a system. I will choose this 6 security group, and then for the network boundwise, I will use a default value 1 megabyte. And the operating system, I will use Windows Server 2012 English version. So you can see here we provide a lot of public image here, like CentOS, Windows, and Ubuntu, and other. You can choose this image directly here. And about the storage, so for system disk, you can choose the disk type, or for Ultra Cloud Disk or SSD Cloud Disk. The performance of SSD Cloud Disk is better than Ultra Cloud Disk, but at the same time, SSD Cloud Disk is the cost is a little higher. So here we will use Ultra Cloud Disk, use the default value 40 GB. And also we want to add a new data disk here. So we will choose Ultra Cloud Disk as well and use the default value 20 GB here. And for the security setting, so because we are creating a Windows instance, so you need to specify the password for the administrator user. So we will input the password like cloud training. Okay. Then user data we don't need this part. You can specify later. For the instance name, we'll input cloud test. Okay, that's all for the information you need to input here. So after this, click the Buy Now. Okay, it will list the detailed configuration of your ECS instance. After confirm, click the Active. Okay, now as mentioned here, the instance you created will take 1 to 5 minutes to complete. So let's go to the console to check the status of this instance. So click the ECS from the main menu of the left and click the instance. You can see that the instance we just created is listed here and the status is starting. So let's wait for a while until the start finished. Because it's the first time the instance was started, so it may take a little longer. Okay, let's wait for a while. Okay, now you can see the status of this instance changed to running. It means that the instance has been successfully created. Yeah, this is demo about how to provisioning a cloud instance. So after the demo, let's do a quick recap about this chapter. So you only need 3 steps to provisioning a customized ECS instance. Register an account and create the ECS instance on Web UI console and submit, and the instance will be available in 3 minutes. Okay, that's all for this chapter. Thank you for watching. Welcome back to Alibaba Cloud Operate and Manage Cloud Server Training. In this chapter, we will talk about how to manage the ECS instance. By using Web UI Console, you can easily manage your ECS instance. You can do following operation anywhere at any time. For example, you can remote login to ECS from the console, and you can restart ECS instance from the console, and also you can modify your login password of ECS instance. You can increase CPU memory at any time. You can also increase network boundwise. If you don't have enough space of your disk, you can expand the size of existing disk or add a new disk. So, how to access the ECS console? To access the ECS console, first you need to log into the Cloud Console and click ECS in the left main menu. Then click Instance from the submenu of ECS. Instance list screen will show up. After choose a region, your instance in the target region will be listed. You can choose the operation from the Manage Menu list. Okay, let's do a quick demo about these operations. Okay, let's start the demo about how to manage ECS instance on console. It includes remote login to the target ECS instance and remote restart and modify the login password and increase the CPU and memory. So from the menu here, you can see there is a lot of operations here like stop, restart, release, instance, and some other operations. And connect here, you can connect to the remote host directly, and there also a change instance type button here, but it's disabled right now, so we will check it later. So first, let's try connect to the remote ECS instance. If it's the first time you log into this instance, there will be a window popped up tell you the VNC connection password. Please memo this password because you will use it every time you try to log in this instance. Okay, now input the VNC password. You just copy it, click OK. Okay, now you can see we have logged in this server, and we will use Ctrl+Alt+Delete to access the login page. Input the password of administrator. Now you are accessed in this server. Okay, you can see we have this is a Windows Server 2012 R2 server, and let's check the memory and disk. Okay, the local server. Yeah, we can check the memory here is as we selected in the instance creation method is 2 GB memory and totally 60 GB disk. Okay, let's close this window and do our next operation. Next, we will remote restart this instance. Just click more here and click restart. It's very simple. Click OK. Now the status of this instance will change to stopping. After stopping, it will restart again. Okay, now the status changed to running. Let's connect this instance again. Use the VNC password and log in. Okay, now we are in. So you can confirm that this instance has been restarted. Okay, next operation is modify login password. Actually, you not only login password can be changed here, you can also reset your VPN password if you forgot the password. Okay, here we will try to modify the administrator user password. Click the reset password. We will input a new password here, and wait. Okay, click to submit. Okay, please be noticed that when you modify the password, you need to restart the instance. Okay, click to restart. Okay. Okay, status changed to starting. Okay, let's refresh it again. Okay, the status changed to running, so we can connect to this instance and try to confirm whether the password has been changed or not. Because we are just changed the login password, VNC password is still the same. Okay, click Ctrl+Delete. Now use the new password you just input. Clicked login. Okay, now we are logging our ECS instance using our new updated password. So we will continue to the next demo. Next, we will change the instance type. Means we will change the CPU and memory of this instance. It's now you can check that the change instance type button has been disabled. Means that if you put your mouse on this button, it will give you a hint. It said, please stop the instance first. Okay, let's follow the hint and stop the instance first. Okay, no, click OK. Now click OK to stop the instance. Now the status of the instance changed to stopping. Okay, now the status changed to stopped. You can see the change instance tab button has been enabled. So click this button. Now choose you the new instance tab you want to update it to. Here we will use medium, use large. So we will change CPU core to 2 and memory to 4 GB. Okay, click OK here. Okay, please notice that you need to start the instance. Let's start the instance and check whether the change has been updated. Okay, start the instance. Click OK. Please notice that our original memory is 2 GB. Now we update it to 4 GB. Okay. Still starting. Okay, now the status is running. Now connect to the server. Copy the VPN password and log in to the server. Input the password, click OK, and let's open the server manager to check the change. Okay, what is our local server information? Oh, it's changed. You can check it here. The memory has been changed to 4 GB. Okay, this demo we showed here is about how to manage instance on the console, about remote login, remote restart, modify login password, and increase CPU memory. Okay. So next we will talk about how to expand the storage of your instance. You have two options to finish this task. Option A is expand the size of the existing disk. Another option is you can add a new disk to the instance. For option A, you need to do when you want to expand the size of the existing disk, you can follow the 3 steps. First, log into the console, choose the target disk, and from the menu, click expand the size. And then go to the console to restart the instance. And last step is for Windows, you need to remote log in to target ECS instance and expand the volume for the target disk from the server management console of Windows. If you want to add a new disk, you can first purchase a new disk which is in the same zone as the ECS instance. If the disk is in a different zone from ECS instance, it cannot be attached. Next, from the console, attach this new disk to the target ECS instance, and then restart the instance. That's all for the add new disk steps. Okay, let's do a quick demo about the expand storage. Okay, let's start the demo about how to expand storage. First, we will expand the size of the existing disk. So the first step is in the console, clicked ECS, clicked Cloud Disk, and from the menu here, so you can check there's two different type. There's one type called system disk, another type called data disk. For system disk, you cannot resize. It cannot be resized. So we will resize the data disk. So, okay, let's click resize disk. Now we will change to 25 GB. So it will list the price here. So you can see it's very cheap. So confirm to resize. Clicked already read. Okay. So it will pop up a window and let you know the resizing is successful. So click back to disk list. So please be noticed that the resize disk operation is also requires instance restart. So we will click the instance and restart the instance. Okay. Okay, let's do a quick refresh. Okay, not yet. Okay, the status has changed to running. So let's connect to the host and to expand the size of the disk. So our original size of the disk is 24 GB. So let's so first go to the server manager and waiting for a while until the file and storage service menu show up. Click here, click the disk. So you can see that the data disk has been changed to 25 GB, and there is a 5 GB unallocated free space here. So we will need to we have to expand the volume for this disk. So click to the volume and right click, click the expand volume. So here we will use the maximum size 25 GB and click the OK. So okay, it's finished, and let's check whether the disk size has been changed. Okay, now you can see our local disk drive D has been changed to 25 GB. Okay, this is the first option to expand the size of the existing disk. You have another option. You can create a new cloud disk and add this disk to the target instance. So from the cloud disk menu, click create cloud disk. Okay, please be noticed that you need to choose the same data center as the instance, or otherwise you will not be able to add this disk to the target instance. So choose Singapore, and the storage tab will use neutral cloud disk. The set use default size 20 GB and click the buy now. Okay, it will give you a cost here and click to activate. Okay, now the disk return to the console. Click cloud disk. Okay, click to refresh. Yeah. Okay, so you can see that the new disk has been created here and the status is available. Now we will attach this disk to our target instance. Click the mouse and attach. Here we will choose our target instance, cloud test, and clicked okay, click the attach here. Okay, so this disk has been attached. Then we need to restart the ECS instance. Okay, go to the instance page, click the more and restart. Click OK. Okay, it's stopping. Still stopping and starting. Okay, click to refresh to check. Okay, the status changed to running. Let's connect to the host. Okay, enter the vacancy password and the administrator, the password of administrator user password. Okay, in this add new disk option, you don't need any other options on the host. It will be automatically added to this server. So click this PC. You can check there's a new local disk. E is created here. Yeah. Okay, that's the demo for expand the disk. So yeah, you have two options here. You can expand the size of the existing disk, or you can add a new disk to the new instance. So please notice that this expand storage operations need to restart the instance. Okay, that's all for the expand storage demo. Okay, after the quick demo, let's do a quick recap of this chapter. From this chapter, you can see all the following operations can be found on the console, such as the remote login, remote restart, modify login password, and tuning the performance, and expand the storage. And please notice that extra simple operation is needed on target ECS instance for expand storage operation. Okay, that's all for this chapter. Thank you very much for watching. See you later. Welcome back to Alibaba Cloud Operate and Manage a Cloud Server training. In this chapter, we will introduce how to deal with some common requirements in a daily operational work. Let's take a look at these two operational scenarios. Scenario 1 is to recover data which was carelessly deleted. I think lots of IT guys encounter this situation as their daily work. If you are using traditional server, you need to have a backup of the data and then recover from the backup. It requires professional skills about data backup and recovery. Scenario 2 is about the real-time monitoring for a server and notification when workload is high. This is also a common task. For a traditional server, you need to develop a monitor and notification tool about this requirement. But with Alibaba Cloud, only 5 minutes is needed for such case. All operations can be done on console with a few clicks. First, let's take a look at how to deal with scenario 1 if you are using ECS. This is a common scenario. In the process of system maintenance, it is often when deleting data by mistake. Also, when to restore the deleted data, you must back up the data in advance and then restore the data from the backup. Let's see the solution in ECS. You can use ECS snapshot feature to quickly and easily restore deleted data. ECS snapshot is the copy of the data on a disk at a certain time. The most common usage of snapshot is to back up data. When an accident happens, like someone carelessly deletes some data, it can be retrieved from through snapshot. And please notice that users can cite auto snapshot policies to back up data automatically. Here is the steps to using snapshot to retrieve the deleted data. First, you need to confirm the disk of the target ECS instance, and then create a new file in the disk and create the disk snapshot and simulate deleting the file from the remote terminal, and then stop instance, roll back the disk using snapshot. And then last is restart the instance. You can confirm the data has been recovered successfully. Okay, let's do a demo about using snapshot to retrieve deleted data. Okay, let's start the demo of using snapshot to retrieve deleted data. Now first, let us confirm the disk of the target ECS instance. Click to the instance page and click the target instance. Okay, from this page, there's a menu here. You can check the instance details, the instance disks, and instance snapshot here. So let's click the instance disks. You can see that we have 3 disks here. Yeah. Okay, let's return to the instance page, connect to the server, and we will to confirm the snapshot feature, we will first create a new file in the D driver, and then take a snapshot and drop the file, and then use the snapshot to roll back the disk, and then check whether the file has been recovered or not. So we will create a new file called snapshot test. Okay, input some value here. This is a snapshot test file. Okay. Save and close. Okay, now we have a new file here. We will first return to the cloud, the instance page. So instance disk, we will create a snapshot for the D driver. Is 25 gigabyte, right? 25 gigabyte. Okay, so we will create snapshot. You can click the create snapshot button, input a snapshot name, cloud test snapshot. Okay, click the OK here. After this operation, you can access the instance snapshot page to check the snapshot details and the status. Now we can see it's still in progress. So according to the data size, the first time of creating snapshot operation may take some time, but Alibaba Cloud using incremental snapshot feature to create a new snapshot. So the second time you create, it will not take much long. Okay, let's refresh the page to check the status. Okay, now the snapshot has been successfully created. Okay, so we will continue our operation. We will return to the host and delete the file we just created for testing. So delete this file and empty recycle bin. Okay, now the file has been deleted by mistake. How can we retrieve this file? Now let's using disk rollback feature here. So at the instance snapshot page, check the target snapshot you want used to roll back the disk. Click the disk rollback. Now there is some notice here. So disk rollback is only supported for stopping instance and for disks without snapshot being created. Because our instance is still running, so we will first return to the instance page and stop the instance. Click the OK. Okay, instance has been stopped. Now access the instance detail page again. Click the instance snapshot. Now use the disk rollback. Click the disk rollback button. Now there's a checkbox here. It will start. If you check this option, it will start the instance immediately after the rollback. So we will check this option. Click the OK. Okay. Now let's move to instance page. You can check the status has been changed to starting. It means that the disk rollback is finished and it's the console is trying to start the instance. Okay. Now let's connect to the target host to check whether the file has been recovered or not. Okay, input the password of administrator user again and click this PC and access D. Oh, you can see that the file we just deleted by mistake has been recovered successfully. Okay. Okay. By using snapshot, you can also set up the auto snapshot policy. Go to automatic snapshot policy under snapshot image submenu. Click here. You can create automatic snapshot policy. Click this button and input the policy name, Cloud Test Snapshot. Okay, here you can choose the time the snapshot has been taken. So we will choose 11 p.m. and every day. Okay, so for the retention period, you can check, you can specify the during days, or you can check the permanent button to make the snapshot permanent. Okay, so we will use the default value. Click to OK. So it will, there's notice here, so it tells you that you need to it is recommended that the disk be set to execute the automatic snapshot policy. So we will set disk. Okay, you can choose the disk you want to add into this automatic snapshot policy. We will check the data disk and click enable the automatic snapshot. Okay. Okay, now everything is done. We can check, click cloud disk, and so you can click the automatic snapshot policy for each disk to check the detail. Yeah, this disk has been added to the snapshot policy cloud test snapshot, and it will create a new snapshot every day at 11 p.m. Okay, that's the snapshot feature. Next, let's take a look at how ECS deals with scenario 2. Here is a common scenario. User needs to monitor the running status of ECS instance, such as CPU usage, memory, disk, and network. In a traditional situation, user needs to set up a server monitoring and alarm system to do this job. Here is the solution in ECS. Alibaba Cloud Monitor can monitor all of the key metrics for ECS instance in real time. Cloud Monitor provides insights into CPU utilization and other performance metrics of ECS instance without additional charge. User can confirm the real-time status and configure alarm policy on console. Okay, here is our demo steps. First, we will confirm the monitor status on console, and then manage the alert contract and configure alert policy. Send alert message to administrators when CPU usage reaches 70%. Okay, let's do the quick demo. Okay, let's start the demo for ECS instance monitoring. I will show you in Alibaba Cloud how you can confirm the monitor status of your instance on the Web UI console, and then show you how to manage alert notifications, how to create alert rules. First, let's move to ECS console, click the ECS and the instance. So you can see there's a monitor button here. You can review basic metrics for this instance. You can see there's a CPU usage and network usage here. This is a basic information. For the detailed information of the ECS instance, you can go to Cloud Monitor dashboard to check the detail. So somebody may found that there's no Cloud Monitor menu here, so you need to click this button and choose the monitor and management menu here, and click OK to let it display on the menu. Okay, so click the Cloud Monitor. Okay, you can check the detail information on the dashboard. So if you want to check the instance status, you need to click host monitoring. So it will list all your instances here. And here, please be noticed that if you want to use Cloud Monitor 2, you need to install an agent on your host. Here you just need to click to install button. It may take about 1 minute. 1 minute to finish. Okay. The agent has been successfully installed on our ECS instance. Now you can click this instance to check the detailed information like CPU usage, memory usage, and some basic monitoring, process monitoring. You can see there's a lot of information here. Yeah. Okay, if you want to add an alarm rule for this instance, for example, configure alert policies, send alert message to administrators when CPU usage reaches 70%. Okay, let's click alarm rule and click here to add one. Okay, so first you need to check the related resource. Here we will use ECS, and resource range choose instances, and the instance name use cloud test. Now it's the threshold, set alarm rules. Alarm rules, let me input a name of this alarm rule. Cloud test CPU alarm. Okay, rule description here. You can choose CPU usage, CPU idle time, idle rate, such as that. Here we will choose CPU usage, and the average CPU usage for 5 minutes is higher than 70%. It will send a notification. Okay, so there is some other information here. Muteful means once an alarm occurs and the problem persists, the interval to send the same alarm. So we will use default value 24 hours here. So the triggered when threshold is exceed 4, we will choose 5 times. Okay, the effective period, we will use the default value. For the notification method part, we will use a default contact group here. Click the contact group and move to the select groups. Okay, notification method, you can choose email or DingTalk, and you can use phone or email ID or other method. You can write some informations about email subject and email remark. Test CPU usage alert. Okay, after that, click to confirm. Okay, now this rule has been created, and the Cloud Monitor will monitor the real-time status of this instance, and if the CPU usage is 70%, reaches 70%, it will send alarms to the specified contact. Okay, that's all for the ECS instance monitoring demo. Okay, after a quick demo, let's do a quick recap of this chapter. So, using ECS snapshot feature, you can quickly and easily restore deleted data. Users can set auto snapshot policies to backup data automatically. You can also configure proper monitoring metrics and alarm policies to monitor the ECS running status. So to operate ECS instance, you can use our web UI console, or you can log in your remote host using remote management feature. Okay, ECS supports various cases and solutions. Here are the overseas customers. You can see we have overseas customers in different industries who are already using ECS as their cloud server to provide their services. There are lots of possibilities waiting for you to explore. I think it's a good start to try ECS instance first. Okay, that's all for the Operate Manage a Cloud Server training. Thank you very much for watching. Goodbye.
Hello, and welcome to this introductory course from Alibaba Cloud, 6th generation ECS, better performance, more choices. In this course, we'll be explaining some of the basic concepts behind the ECS service, and we'll be talking about some of the advantages of the new 6th generation ECS hardware. Here is our agenda. We'll start out in part 0 by discussing what is ECS. In part 1, we'll discuss some of the advantages of the new 6th generation ECS hardware. In part 2, we'll move on to understanding instance types and families. In part 3, we'll look at how you can use your instance type and family knowledge to choose the right instance type for your workload. In number 4, we'll explain ECS's different pricing models. And then in part 5, we will have a hands-on where we show you how to purchase an ECS instance from the Alibaba Cloud console. Let's start at the very beginning. what is ECS? ECS stands for Elastic Compute Service. This is essentially Alibaba Cloud's virtual machine service. An ECS instance is just a virtual machine. Compared to a physical server, an ECS instance can be deployed immediately and automatically and can be backed up, cloned, or replaced at any time. So what does an ECS instance include? Well, you can break this into the hardware and software layers. On the hardware side, each ECS instance will have some amount of CPU and memory, the amount of CPU and memory being determined by the instance type, some amount of block storage, which we call cloud disk. You can easily make point-in-time snapshots of cloud disk anytime you want. And then an Elastic Network Interface, or ENI, which is the network interface that the ECS instance uses to communicate over the network. On the software side, there are operating system images, which are used to create the ECS instance's system disk. These include an operating system such as CentOS, Windows Server, or Ubuntu, and you can also make your own custom operating system images. Then there is the security group, which acts as a stateful firewall for the instance. Let's discuss some basic ECS concepts. In addition to cloud disk or block storage, which every ECS instance has, you can also attach ECS instances to other Alibaba Cloud storage services over the network. So you can attach ECS instances to NAS, which is our shared file storage, its network attached storage, and OSS, our object storage service. Both of these services have private internal network endpoints within Alibaba Cloud, so your ECS instance does not need to connect to the internet to use these network services. Cloud disk, and again every instance has at least one because the system disk holding the operating system is a cloud disk, can be broken into three types: UltraDisk, SSD, and eSSD. UltraDisk is a traditional hard drive. SSD is a solid-state drive, and eSSD is an enhanced solid-state drive with higher I/O performance. Newer Generation 6 ECS instances all use eSSD. Let's now take a look at networking. Every ECS instance lives inside of a virtual private cloud. This is a private network environment that contains this ECS instance, as well as possibly other ECS instances and connectors to other services like our database service. Inside of the VPC, you will have a vRouter, which is a hub that connects the vSwitches in the VPC and serves as a gateway between the VPC and other networks, as well as at least one vSwitch. A vSwitch is a virtual switch. This is how your ECS instance connects to the VPC. Let's quickly get some terminology out of the way before we go any further. First, there is the ECS instance. This is equivalent to a virtual machine, and this will include the CPU, memory, disk, network, and operating system configuration of the ECS service. That is an ECS instance. Then we have the instance family. Instances are grouped into families which map onto different business scenarios. The CPU to memory ratio of your instance will be determined by its family. Some instances may also include additional special purpose hardware like GPU or FPGA cards. Then there is the instance size. This is essentially the number of vCPUs or virtual CPUs allocated to the instance. For instance, a 2x large instance type would have 4 vCPUs. Then there is the image. As we just discussed, this is the operating system and other software that's used to boot the instance. Block storage, this refers to cloud disks, but it can also refer to local disks. Some instance families include a local disk, which is a solid-state drive that's physically attached to the instance itself. Then there is the snapshot. This is a convenient and efficient cloning and disaster recovery tool. It's a point-in-time copy of everything on an instance's disk or disks. Then we have the security group. This is a virtual stateful firewall which protects the instance. After that, we have the IP address. Each instance will have a private IP address which allows it to communicate within its VPC group, but it may also have a public IP address which allows it to communicate with the internet. The public IP address is optional. And then finally we have the concept of a region and an availability zone. A region is a geographical area such as Singapore or Hong Kong, and an availability zone is a data center within that region. So for instance, in Singapore we have 3 physically separate data centers: Zone A, Zone B, and Zone C. Within a given region, These zones will be linked together using low-latency private network links. I also want to take a moment to discuss block storage. ECS instances utilize Cloud Disk as the primary mechanism for block storage for both system and data disks. Now, the nice thing about Cloud Disk is that it stores 3 redundant copies of the disk's data separately on different physical machines attached to different network switches. Remember, Cloud Disk is a type of virtual disk that's actually made available to the ECS instance over the network. So it's possible to store multiple replicas of Cloud Disks, and that is in fact what we do in order to improve reliability and redundancy. Newer instance types use our enhanced SSD as the physical storage backing the Cloud Disk. This allows up to 1 million I/O operations per second and a throughput of up to 4 gigabytes per second with a latency in the microseconds, typically between 100 and 150 microseconds. eSSDs are categorized into 4 performance levels, PL0 through PL3. PL0 is fine for most applications and for the system disk. This is the storage class we are using to replace our older SSD and UltraDisk types on our newer ECS instances. So newer ECS instances will typically use eSSD. If you're looking for the cheapest eSSD, then you want PL0. On the other hand, if you're running a very high-performance search or relational database application, you might want to consider PL2 or PL3, which offer much better IOPS and much better maximum throughput. Sixth generation. What's new? So the first thing that's new is our new 3rd generation X-Dragon architecture. This is the architecture we use on our physical machines in order to enable our VMs to run more efficiently. At the heart of the X-Dragon architecture is our Dragonfly hypervisor, which is coupled with our X-Dragon chip. So we have a physical hardware device installed on our physical servers that actually serves to accelerate memory and network access for the virtual machines that are running on those physical servers. So each physical server has this X-Dragon subsystem that includes a chip-accelerated I/O engine, which allows for higher performance and lower latency, as well as reduced network jitter. We have hardware-level quality of service management, network and storage QoS for multi-level scheduling. We also have an enhanced convergent network and enhanced hardware queuing, all as a result of installing this X-Dragon hardware on each of our physical machines. Now we also have what we call our new enhanced Generation 6 instances, and this is what I really want to talk about in this course. So if you look at the enhanced Generation 6 instances, these are a combination of the Dragonfly hypervisor plus our 3rd generation X-Dragon architecture plus enhanced SSD. So all Generation 6 enhanced instances are equipped with enhanced SSD. So what does that get you? Well, it gets you better network capabilities, 4 times higher packet per second throughput rate than our previous generation ECS instances at 24 million packets per second, burst bandwidth up to 10 gigabits per second, and up to 50% lower network latency. Same thing in storage. It's a big improvement over our previous generation ECS. All new Generation 6 enhanced machines are equipped with enhanced SSD, so storage latency has been reduced to 100 microseconds, so between 100 and 150 microseconds, and a single instance can achieve up to 480,000 I/O operations per second. This also leads to improvements in application performance. In benchmark tests that we have run, we have a 25% improvement in running MySQL workloads, a 100% up to a 100% improvement in running Nginx workloads, and up to a 15% improvement in running Redis workloads. We've also been able to improve our availability and stability. Our single instance availability is now 99.975%, and we base our SLA on this. So we now have an industry-leading SLA higher than our competitors. Our multi-zone, multi-instance availability is now 99.995%. In terms of stability, the Dragonfly hypervisor provides us with super lightweight virtualization and is very well tested and very stable. It's the same hypervisor that we use to run our own VMs during 011, and it also has some tweaks and tuning built in to help deal with and achieve stable performance for multi-EBS storage, so for multiple block storage devices. if you were to perform a head-to-head between Generation 6 and the new Generation 6 Enhanced, these are the key differences. The CPU configuration is essentially the same, network bandwidth is the same, but the packet per second throughput for the network cards has been improved from 6 million packets per second to 24 million packets per second. Network latency has been reduced to about 25 microseconds from 32 to 53 microseconds, so things are faster. In terms of storage, the number of I/O operations per second, we've gone from 200,000 up to about 480,000. Latency, again, has been reduced for storage from 250 microseconds to read, or about 160 microseconds to write, down to 200 microseconds to read and 113 microseconds on average to write. So read and write are both faster for the new enhanced SSD. Bandwidth is the same, and instance-level QoS is built in on both 6th Gen and 6th Gen Enhanced. So the majority of what we have here is speed improvements, especially for our network and block storage devices. It's obvious from the data we've seen so far that Generation 6 Enhanced and Generation 6 are a big improvement over Alibaba Cloud's other ECS instance classes, our older hardware. But how do we stack up against our competitors? So it wouldn't be fair for Alibaba directly to do that kind of analysis. So let's take a look at what a third party thinks. So this is data from Gartner's Solution Scorecard for 2020 in the compute category. The Solution Scorecard evaluates IaaS capabilities of multiple different cloud vendors, and it includes hundreds of different scoring requirements across multiple categories. So in the 2020 Gartner Solution Scorecard, Alibaba's ECS beats AWS and is ranked first worldwide. This is the first time we've achieved this. We're the only cloud provider in the world as well to achieve a perfect score in both the required and preferred category for our ECS service. So we've achieved about as good a score as we can manage. Our overall score has also greatly improved since 2019, thanks to the updates and continuous improvements we've made to the ECS service. Gartner's overall conclusion for Alibaba Cloud changed from last year's suitable for specific scenarios to suitable for general scenarios. So we're now on par or even better than most of our major competitors in the cloud computing IaaS space. ECS instances, types and families. So let's first discuss ECS instance naming rules. So every ECS instance type is going to start with the prefix ECS. This is just the product name. You can usually ignore that because all of the ECS instances will, of course, start with ECS. Then there is the instance family, which includes the generation, and the instance size. So the instance family will give you an idea of what type of hardware the instance is likely to include and what type of workload it's suited for. For instance, here we have HFG. This is a high-frequency general-purpose instance, and it is a 6th generation instance. You might, in practice, in production, see generation 4, 5, and 6. You're unlikely to see anything older than that, and nothing newer than that has yet been deployed, although generation 7 is on the way. Instance size will be at the very end of the instance name. The size indicates how many virtual CPUs the instance has. So a large will have 2 virtual CPUs, an X large will have 4 virtual CPUs, and a 2X large will have 8 virtual CPUs. Typically, the pricing also doubles as the number of vCPUs doubles, so keep that in mind. There are a wide spectrum of compute instance families for all different kinds of workloads. The most common are the G, C, and R class. G is general purpose, C is compute-oriented, and R is memory-oriented. There are also a variety of special purpose classes, which we'll talk about later, such as the VGN or GN class, which include a GPU, the F3 class, which includes an FPGA, and the NPU class, which is designed for AI and machine learning tasks, and includes the Ali NPU, which is accelerator hardware to help with training algorithms like TensorFlow. Then there is also the T6 class, all the way on the lower right here, which is a special type of burstable instance that's designed for workloads that normally have very low CPU utilization. So to take a higher level view of this chart, the items in orange on the left of the chart are traditional x86 hardware. This encompasses our standard ECS virtual machine, our dedicated host product, and our bare metal instances which have no virtualization and which I will talk about later. On the right, we have heterogeneous computing in yellow. These are machines that include special purpose hardware like FPGA cards or GPU acceleration. Then on the very far right, in gray, we have our HPC or high performance computing line. These are machines that are designed for industrial simulation or genetics or other supercomputing tasks. They're designed to be clustered together, so they include high-speed convergent Ethernet and RDMA support. We have different ECS configurations. Generally, multiple ECS types or families can be run on multiple different ECS configurations. The four that you should know about are ECS VMs. This is the standard ECS virtual machine. This is what most customers buy. But we also have a special configuration called a DDH or dedicated host. So ECS VMs live in a multi-tenant environment. Your virtual machine might be on a physical machine that also has other users as tenants. So multiple users might have their VMs located on the same physical machine managed by Alibaba Cloud. If you compare that to DDH, DDH's unique feature is that all of the virtual machines running on the physical hardware belong to you. So there's the physical server and the virtualization layer are still managed by Alibaba Cloud, but all of your virtual machines are running together on the same dedicated physical host that belongs only to you. No other user's virtual machines will be placed on that host. Then finally, there's bare metal. So bare metal is a single tenant physical server that has no hypervisor. So if you wanted to directly run a Kubernetes cluster or a container-based workload without the overhead of virtualization, bare metal can give you that. If you needed special hardware support, like for Intel VTX or SGX extensions, this would also be a good choice. If you're running software like an Oracle database, where you're not allowed to re-virtualize because of the terms of the Oracle database license, then bare metal is a good choice. Oh, also, I shouldn't leave out ECI, although we won't really discuss it in this course. ECI is an elastic container instance. This is a system that allows you to basically run what we call serverless containers. So you can deploy Docker containers onto ECI, and it will automatically allocate ECS virtual machines to run those containers for you. So you don't really have to think about how much hardware you need up front. So here is the general recommendations we have for most common workloads. What type of instance should they run on? Well, in general, Apache or Nginx or load balancers can run on the C, G, or HFG class instances. These are the compute, general purpose, and high frequency instance types. Middleware services like Spring Cloud or Dubbo or message queues, again, can run on G6, HFG, or C6 even, although typically we'd recommend G6 because of the higher memory requirements. App servers like Tomcat, Jetty, JBoss, these again can run on G6 or HFG, which is just a high-frequency general-purpose instance. Caches, Redis and Memcache, these are very memory-hungry applications. These should run on an R-class instance or an HFR, which is a high-frequency, high-memory instance. Databases should run on an R6 instance, which again is an instance with a lot of memory, plus we recommend that you actually choose an R6E, which is a 6th generation enhanced R-type instance, because that will have enhanced SSD attached. You really do want fast disk for a production database. You could also run a database on an i3 or i3G instance, which is an I/O enhanced instance that has its own local physical disks. Big data, HDFS, MapReduce, Spark, these kind of workloads should run on a D2S or D2C. These instances are targeted for big data applications and are tuned to run things from the Hadoop ecosystem. AI and ML, you should consider the GN instance types, which have a built-in GPU. These are suitable for running TensorFlow, MXNet, Caffe, and other open source big data and machine learning frameworks. Let's next talk about choosing the right instance type. We'll go into a little bit more detail about how to choose instance types here. So the G, C, and R type instances are general purpose instance types. So G, C, and R, let me explain what those are. G is general purpose, C is compute, and R is memory. So general purpose instances are suitable for almost any workload. This is the default choice if you aren't exactly sure what type you should use. C is the same as general purpose, but with a higher vCPU to memory ratio. And R is the same as general purpose, but with a higher memory to vCPU ratio. So R machines have more RAM, C machines have more CPU, and G provides a good balance between the two. We also offer high-end CPU offerings and very high capabilities on the network and storage side. So these instances are powerful. Despite being general purpose, they are very powerful, very capable, and if you choose the G6E, C6E, or R6E types, these are the enhanced Generation 6 instances, and they include eSSD. They include enhanced SSD, as well as Intel Cascade Lake CPUs with clock speeds up to 3.2 gigahertz. So these are suitable for a wide range of applications. The most common workloads are things like Nginx, Docker, Kubernetes, Redis, Memcached, different types of middleware solutions, Java or Python applications, production databases, etc., etc. As I said, you can run almost anything on these. Then there are the high-frequency instances. These are the same as the G, C, and R type instances, except that the name starts with HF, which indicates that it is a high-frequency instance. So if you're buying an instance and you see that the instance family includes HF, this indicates that the instance has a higher clock rate. It includes a faster CPU. These are a better fit if your workload is very CPU heavy because of the higher CPU performance. These instances have Copper Lake CPUs with a burst frequency up to 3.8 gigahertz and also BF16 instruction set support for AI workloads. So these are also a good choice for non-GPU AI workloads. Big data instances, this is the D2S and D2C class instances. So these are instances that include local hard drives, actually local solid state drives, I should say. So the advantage here is that these instances have a local disk that's physically attached to the instance. The traditional cloud disk block device that our ECS VMs use is actually network storage. It is very fast, it is very low latency, but it's not physically attached to the machine. It's on a network storage device somewhere nearby. With the D2S and D2C instances, there's actually cost-effective local HDDs right there ready for you to use. The D2S is storage optimized. This is for storage-heavy workloads. D2C is compute optimized. So the D2S features Intel Skylake CPUs and up to 38 terabyte hard drives with up to 35 gigabit per second bandwidth between instances. So you can cluster these. They do have very fast network, and the instances provide 2 hot swappable redundant local hard drives, which you can swap in to replace failed disks, which can help to reduce downtime when a disk failure occurs. D2C uses Intel Cascade Lake CPUs and can support up to 12 4 terabyte hard drives, again with 35 gigabit per second network bandwidth between instances. One important point here, cloud disk storage, one of the major advantages of cloud disk, which we discussed when we talked about what is ECS, is that cloud disk stores redundant copies of data. Local disks don't do that. Local disks are just ordinary local hard drives. There's no storage management or redundancy management layer on top of that. These are just disks. So if they fail, you will lose data. So your application should have built-in redundancy to cope with this. So if you're running something like Hadoop's HDFS, that's fine, because HDFS is actually built to survive disk failure. So if you cluster D2S or D2C instances together and you run HDFS across them, you'll be okay. Because if a disk fails, HDFS will handle that for you. But if your application doesn't have that built-in redundancy, you've been warned. If a disk fails, you will lose data. So the big data workloads you would typically run on a D2S or D2C are things like Hive, HBase, Spark, Elasticsearch, MapReduce jobs, JindoFS, HDFS. You could also use them for log data and data processing applications like Kafka and Flume. Okay, local SSD instance, or i3. There are 2 variants of the i-series, the i3 and the i3G. The i3 focuses more on workloads that need more high-performance local SSD, while i3G focuses more on computing. So the i3 includes, again, Intel Cascade Lake CPUs. These go up to 3.2 gigahertz all-core turbo. These machines have up to 768 gigabytes of RAM and up to 12 1.8 terabyte high-performance local SSDs attached to the instance. The network bandwidth is up to 32 gigabits per second again. Compared with the older i2, the i3 supports NVMe protocol for these local SSDs, which significantly improves performance in terms of both latency and throughput for these local disks. So this is a good choice if you need really, really high local solid-state drive performance. Caution, again, the local disks are not cloud disks, and they do not have built-in redundancy like our cloud disk service has. So data will be lost if the disks fail. You need to have application-level redundancy, again, to deal with this. So what sort of workloads would you run on an i3? An OLTP database system like MySQL, Microsoft SQL, or PostgreSQL, maybe a NoSQL database like MongoDB, Cassandra, HBase, or Redis. You could run Elasticsearch. Again, RabbitMQ or Kafka would run on this type of instance. And of course, you could easily run Hadoop on this type of instance, just as you could with the D2S or D2C. Then there are the burstable instances. These ones are interesting. Actually, these are what you would use if you have a testing workload or you're just getting started and you want to try to save some money. So these are perfect for use cases with low average CPU utilization. So if your instance spends 90% of its lifetime using less than 20% of the allocated CPU, these instances are great because they're much cheaper than equivalent general purpose instance types, sometimes 20 to 50% cheaper. The T6 and T5, so T6 is 6th generation, T5 is 5th generation, they both provide a baseline CPU performance that's between 5 and 40% of the CPU with the ability to burst CPU usage up to 100%. So how does the bursting work? Well, there's a credit system that's used to allocate CPU time. So T6 and T5 instances will accumulate CPU credits when a workload is below the baseline value of maybe 5 to 40% CPU use. Each credit you earn provides the T6 or T5 instance with the opportunity to burst up to 100% of one CPU core for 1 minute, or 50% of one CPU core for 2 minutes. So the CPU credits you have can be used to buy you essentially more CPU time. When you are below the baseline, you'll typically accumulate X number of credits per hour, with the number of credits you earned scaling with the instance size. So for instance, a T6 large has 2 vCPUs and 512 megabytes of RAM. If you use less than 5% of the CPU, then every hour you will accumulate 6 CPU credits, which means that if you need to burst up to 100% CPU usage for 6 minutes, you can do that after the instance spends an hour idling. And you can earn up to 144 credits. There is a maximum. You don't just keep earning credits forever. So once this instance has earned 144 credits, you've reached the maximum and you stop earning new credits. But if you were to look at a 2x large instance that has 8 vCPUs and 32 gigabytes of RAM, this instance can use up to 40% of the CPU and still continue to accumulate new credits. It earns 192 credits an hour, and it can have up to 4,608 credits total. So you do get more ability to utilize the CPU bursting mode with the larger instance classes. If you're really worried about your CPU usage being throttled, if you're worried you might run out of credits but still need to complete some task or some workload, then we do have an unlimited mode, where after you use up your credits, the instance can continue to use 100% of the CPU, but we charge you. We charge you essentially for the additional credits you're burning. But if you're frequently using up your credits, you really should consider moving away from the T6 or T5 type and looking at the general purpose instances, because using unlimited mode is expensive. In many cases, it will be more expensive than just using regular pay-as-you-go general purpose instances. Then there's GPU instances. These are designed for all kinds of machine learning and artificial intelligence tasks, speech synthesis, natural language processing, recommendation and prediction, speech and face recognition, real-time rendering as well. You can do graphics and rendering on these machines. They do have GPU cards built in after all. 3D design, industrial design, scientific computing, Essentially, the advantage here is that Alibaba GPU instances provide both high-performance infrastructure and an AI acceleration layer for TensorFlow and other common frameworks. So we actually have an AI accelerator built into our GPU instances that actually helps to boost performance. We call it AI ACC. And we've actually used this in competitions. The AI ACC layer, we used it on the DawnBench ImageNet test from Stanford, and we actually took first place. We beat all of our competitors in terms of training time. So we were able to take first place in that competition because of this AI accelerator, and it works for TensorFlow, Caffe, PyTorch, and MXNet. We also support multiple storage options for our GPU instances. So in addition to regular cloud disk block storage, we support NAS, OSS, and CPFS parallel file storage. Then there is the dedicated host, which we often refer to simply as DDH. This is a good fit for traditional finance, manufacturing, and commercial customers. Internet customers, like gaming companies, might also find this instance useful. It's a great way to start your migration to the public cloud, and the key advantages here are security and performance. Because you are the only tenant on the physical machine, you can be guaranteed that no other user's virtual machines are going to use up your resources. Also, you get great security because, again, you're not sharing this physical machine with any other Alibaba Cloud users. Key features include the ability to create custom instance classes. So you can create ECS VMs on a dedicated host that have custom CPU to memory ratios that we don't normally support. You can also oversubscribe the CPU on purpose. So you can actually customize CPU to virtual CPU ratios, which allows you to run more virtual machines on the hardware than you have CPU cores for. This is fine in most cases because each VM won't be using 100% of its allocated CPU. Bare metal, this is very similar to the dedicated host. Again, it is physical hardware that is allocated to you that other customers do not use. The key difference here is you can run ECS VMs on top of a dedicated host, but you can't do that on bare metal because bare metal has no virtualization layer. So bare metal instances are great for doing re-virtualization or custom virtualization. If you want to run Hyper-V or VMware or KVM directly yourself, you can do that on XDragon bare metal because the bare metal machine doesn't include its own virtualization layer, so you can add one. You can also use bare metal for workloads that require direct hardware access. Maybe you need access to Intel's VTX or SGX instructions. You can use those on a bare metal instance. So the key advantages here are high performance, fast deployment of container workloads. If you are running one of those, you can use a third-party hypervisor. And unlike a physical server in your own data center, ECS bare metal can be allocated and delivered in minutes and can seamlessly connect with other Alibaba Cloud services. So even though it is a bare metal machine, you can put it into an Alibaba Cloud VPC network group. It can use all of the internal Alibaba Cloud endpoints for all of our services. It connects to them just as though it were an ECS VM. We also have a few unique instance types. These provide unique capabilities or hardware for special purpose workloads. So the C6T and G6T, these have a trusted platform module, and we actually export that to the VM level. So you can do trusted boot inside of your VM if you're using a C6T or G6T. This would be important in the banking industry and finance, or if you have very strict security and compliance requirements. There's a G6 SE. This is a storage enhanced Generation 6 instance. These instances support up to 1 million I/O operations per second at the instance level, with the lowest block storage latency and throughput that we're able to support currently. So these are good for high-performance databases, search, self-built or custom file systems. And then there's G5NE and G7NE. These instances support up to 16 million concurrent sessions and 24 million packets per second network throughput with low latency. These are really designed for gateways, self-built load balancers, firewalls, and routers. And then there's RE6P. This is really cool. This is an instance with Intel Optane. If you don't know what Intel Optane is, I won't go into a lot of detail about it here. You should definitely go Google it. Intel Optane is super fast, solid-state, persistent storage that's actually so fast you can essentially use it as RAM. So this would be great if you're running Redis or SAP HANA or a parameter server or doing log or video processing, basically anything where you need super high performance access to persistent storage. You can use it almost like RAM. Intel Optane is a very cool technology, and you should definitely go read about it if you're not familiar with it. And the RE6P instance supports Intel Optane. We now come to the most important topic of all, understanding ECS pricing. How do you get the best value for your money? So we'll start by taking an overview of some of the pricing modes on Alibaba Cloud, starting with reserved instances. So reserved instances, or RIs, offer a discount based on a usage commitment. So you commit to use Alibaba Cloud resources for a certain amount of time, and then we provide you with a discount. So the RI, or reserved instance, is a hybrid between pure pay-as-you-go and pure subscription. So originally, Alibaba Cloud only offered two models. Subscription is where you pay up front for a month or several months or a year. Pay-as-you-go is where we charge you hourly and then give you a bill at the end of the month based on your hourly usage. RI is sort of a hybrid between those two. The issue is, if you're using pure pay-as-you-go, you get no discount for using it long-term. But if you're using subscription, you get a discount, but you're not able to flexibly delete or move your instances to another zone. The subscription is tied to the instance, and you can't delete the instance until the subscription expires. So how can you get the benefits of a subscription discount with the flexibility of pay-as-you-go? That's what RI does. Essentially, RI acts as a coupon. When a pay-as-you-go instance is launched, payment will be deducted directly from a matching RI. So if there's a matching RI, then rather than being directly charged your monthly bill, your pay-as-you-go charges will be applied against that RI, and you'll be given a discounted rate. Another big advantage is that the RI can apply to an entire region, so you can move your instance between zones if you want to, and you can split RIs up. So if you have an RI that's good for an ECX G6 2X large, you can actually use that RI to launch two regular X larges. So you can actually launch two smaller instances using an RI that was intended for a single bigger instance. There are three payment methods for RIs: no upfront, partial upfront, and full upfront payment. So the reason for the different upfront payment options is that we offer different discounts based on which choice you make. And you have 3- and 5-year commitments. 5-year commitments aren't launched yet on our international website on alibabacloud.com, but they are coming soon. These long-term commitments will give you a deeper discount. Sometimes, if it's for a 3-year commitment, it can be up to 45% off. If it's a 5-year commitment, it can be up to 60% off the normal monthly price. So here's the pricing strategy and the level of discount that you receive. For the 1-, 3-, and 5-year commitments, you can see that the discount scales both with the amount of time you're willing to commit and with how much upfront payment you make. So if you make an all upfront payment with a 5-year commitment to use those resources, you get a 62% discount off the regular price for the instance. So the all upfront, partial upfront, no upfront, and 1-, 3-, and 5-year commitments give you a wide range. They give you a lot of flexibility in how you purchase your RI based on how long you think you're going to use these Alibaba Cloud resources. So what about network and storage? The RI gives you flexibility and long-term use discounts for compute, but it only covers ECS itself. It doesn't actually cover the cost for disk or network. So to achieve discounts for bulk usage of storage and network, we have two other concepts we need to introduce. One is the data transfer plan, and one is the SCU. So the SCU is a storage capacity unit. This allows flexible discounts for long-term commitment to storage use. It's similar to an RI, but for storage. And the SCU plans range between 1 terabyte and 50 terabytes, and they can span either multiple zones in a region or multiple regions. And the best part is these apply not only to cloud disk, but also to network-attached storage, OSS, and snapshots. So again, just like with an RI, the longer your commitment, the higher the storage discount you receive. Then there's the data transfer plan. This is for network traffic. This has monthly and annual subscription types ranging between 50 gigabytes of network traffic and 50 terabytes. And again, this applies to ECS public IP addresses, so ECS public network traffic, as well as our other network-facing services like load balancer, NAT gateway, and elastic IP. And again, these are designed to give you long-term committed usage discounts for storage and for networking. I should point out, by the way, that for SCUs and data transfer plans, the payment method is all upfront, so you do pay for these upfront. Whereas for RIs, for ECS, you can choose no upfront or partial upfront. Then there are preemptible instances. These give strong discounts for batch workloads or occasional use scenarios. So what do I mean by occasional use? Well, preemptible instances let you bid for unused Alibaba Cloud inventory. Essentially, they give you a big discount on the normal pay-as-you-go price. So the way this works is Alibaba Cloud, as a cloud vendor, has to allocate large amounts of hardware in each of our data centers to make sure that we can meet demand whenever users want to purchase an instance. But what that inevitably means is that a large amount of this hardware is sitting idle, sitting unused by us, unused by our tenants, our customers. So what we want to do is increase utilization, and preemptible instances let us do that. Basically what we do is we let you submit a bid. It's a price per hour that you're willing to pay for this unused capacity, and if your bid price is higher than our asking price, then we launch your instance. Each instance is guaranteed to run for at least an hour, but after that it can be reclaimed. We will give you a 5-minute warning before we reclaim the instance, but we can take it back. So these instances are really good for batch computing, stateless applications, non-production workloads. It's just a regular ECS VM, but at a very, very low pay-as-you-go hourly price. And you can change your bid if you want. So you can adjust your bid flexibly to match our asking price if you want your instance to keep running. But essentially, this is a way to get a big discount for batch or temporary workloads. If you're curious about how the actual preemptible instance bidding process works, there's a flowchart here in the lower right-hand corner of the slide that shows the process from creating instance to termination. Basically, if your bid, the amount you're willing to pay per hour, is higher than we're asking for, and we have sufficient inventory, then your instance will launch and will run for at least an hour. After an hour, every 5 minutes, we'll compare your bid to the asking price, and if your bid is no longer higher than the asking price, we may reclaim your instance. If your bid is greater than or equal to what we're asking per hour, then your instance will continue to run either until you choose to shut it down or until we reclaim it due to your bid no longer being higher than our asking price. Okay, so how do we choose the right model? You've seen preemptible instances, reserved instances, and SCU and data transfer plans. How do we put these things together? Based on your workload, what should you choose? Well, here is a handy chart to help you out. So if you have concurrent workloads, like you can see at the top of the slide, where you have several different workloads that are running at the same time and their usage is related. So when one workload's resource use increases, the other workload's resource use also increases, as you can see with the blue, orange, and yellow bars on the chart. Then you want to consider pay-as-you-go or RI plus pay-as-you-go as your payment model. This way you can flexibly scale up and down. If you have a very steady long-term workload, you could use pay-as-you-go or RI plus pay-as-you-go for some of your workload, but you should really consider either long-term full upfront RI or traditional subscription. For spiking or bursting workloads, the obvious choice is pay-as-you-go. You could also consider preemptible if some of these workloads are not time sensitive. And then if you have mixed usage, multiple workloads that are changing and are not directly related to one another, so some workloads need to burst now, other workloads don't, then you can consider either pay-as-you-go or RI plus pay-as-you-go if your resources are all of the same instance family, because the RI, again, can be split flexibly for instances that are within the same family. So in general, just keep this in mind. If you have a steady workload, subscription or long-term RI with upfront payment. If you have a changing or bursting workload, preemptible plus pay-as-you-go. Okay, so let's now have a hands-on demo. Let's see how we launch an ECS instance. So here we are in the console. Let's have a quick demo to see how to launch an ECS instance. So what I'll do is I'll click on Elastic Compute Service. That will open up a new tab, which will take me to the ECS console. From the ECS console, there's a button here that says Create Instance. Go ahead and click on that, Create Instance. And that will take me to the instance buy page. And you'll see I have three choices right now: subscription, pay-as-you-go, or preemptible. So what I'm going to do is choose pay-as-you-go. If you want to buy an RI, you actually don't do that from the purchase page. You need to do that in advance. So what I'll do is I'll select pay-as-you-go. I then have to choose a region and a zone for my instance. So here I have China Shanghai as my default. Let me change that over to Singapore. So we'll choose Singapore instead. So I'm now choosing Singapore, and I'll choose, let's say, Zone A. And the zone you choose may have an impact on what instance types are available, because each instance type in a region is defined by what hardware was installed in that region. So not every region and zone will have the same hardware. So you can see I can choose heterogeneous, x86, or bare metal here. And then I have general purpose, compute, memory, big data. All of those types we discussed are available here. Burstable is actually called entry level. What I'll do is I'll choose general purpose, and I'll choose a G6E. So this is a Generation 6 enhanced with an Intel Xeon Cascade Lake processor. It can handle 900,000 packets per second with storage IOPS up to 21,000. So this is a fast instance. And I will go ahead and choose a disk image to put on my instance. Let's go with Ubuntu 20. We'll use Ubuntu 20, the latest and greatest. You can see here the default disk type, and the only choice for the Generation 6 Enhanced is the SSD, Enhanced SSD. And I have a 40 gigabyte disk. If I make that bigger, I actually get, I may actually be granted more potential I/O operations per second, and you can see that that is the case. If I go up to, let's say, 500 gigabytes, I now have 7,800 IOPS. If I scale back down to 40, then I have 2280. And I can choose my performance here. PLO or PL1 are available in this zone that I selected in Singapore. I can also set a snapshot policy to automatically back up my disk on a schedule, or I can attach network-attached storage. I'll now go to the networking page. From here, I need to select a VPC in which to launch my instance. I have two VPCs in Singapore. I'll choose the web VPC. I then can choose whether or not to assign a public IP. If I check this box, I am granted a public IP, and I can choose its peak bandwidth anywhere from 1 megabit per second up to 100 megabits per second. I then select a security group. Every ECS needs to be a member of at least one security group, which is essentially a set of firewall rules. And then I can assign one or more elastic network interfaces. In my case, I'll assign a single ENI with a single private IP. And then I'll click on Next to go to the configurations page. This is where I do things like set SSH keys or passwords. I'll go ahead and choose a password here. Oops, let's wait for that to get typed in. The page is a little slow right now. Okay, and then I will go down to instance name, and I'll give this instance a name. So we'll call it, I don't know, web server. Maybe I want my general purpose instance to run Apache. So we'll call it web server. So let's do that. And then I can choose to give it a host name if I want. We can do that. Let's call the host name also web server. If I'm launching more than one instance at a time, I can choose to give the instance name or host name a suffix so that there will be a number at the end of increments like web server 1, web server 2, etc. I can also turn on release protection, which will prevent users from deleting this instance if I'm worried about that. And I can attach RAM roles, which is a way to give my instance permissions to talk to other Alibaba Cloud services. I can then add tags, which will allow me to identify my instance more easily later. And I can add my instance to a deployment set. This will actually ensure that the instance gets deployed onto a particular dedicated host. So I can create a DDH and then make sure my instance launches on that DDH. And then we'll go to preview. We can see the configuration for our instance, the instance type that we selected, the disk type, the zone and region, the disk image, so the operating system version, how many we're going to buy, our billing method, our network configuration, and other information like how we're going to log in. If I want, I can even save this instance as a launch template, which is essentially a copy of all these configurations that I can use to quickly launch identical ECS instances in the future. And here's a cool feature. If you're doing development, you can choose automatic release. which will cause this instance to be automatically deleted at a particular time. I will turn this on because I'm worried that I'll forget. So after I do this test, after I film this video, I might forget to turn my instance off. That's okay. If I check this box and choose a time, then the system will automatically delete my instance for me. I then have to agree to the terms of service, and I click Create Instance, and that's it. That should start the process of creating my ECS instance. And you can see I now have an instance ID, which means the instance was successfully created and is now launching. I can close that tab, and let's go to the instances list in the ECS console for the region Singapore. So I need to switch from Shanghai over to Singapore. And I should now see I have an instance that's in the starting state. So my instance is right here, starting up. And this is its public IP and its private IP. Once it's booted up, maybe we can SSH in and try installing something, just so you can see how that works. So let's go ahead and SSH into this instance. Okay, there we go, and we're in. So now let's say I run apt update, and then let's say we install Apache, and we'll go see if the Apache default page loads up. Or we could put our own web page up. I'm just not sure whether or not we have time for that. Let's see. So apt install Apache 2. There we go. Okay, Apache is now installed. If I want to make sure that Apache is going to boot up every time the instance reboots, then I need to also run this. And you'll notice that I'm logged in as root, so I don't need to use the sudo command. I don't need to use sudo to get root permissions. The default login for all ECS instances is root, so I'm logged in as root. So if I now take this IP address and paste it into my browser, I can see the Apache default page. And just to prove that this is really my server, let's go ahead and change that to something else. So I'll change index.html to something of my own. We'll remove the old one and we'll make a new one. So I'll make a new one. I'll just do this from memory, my new page. Okay, that should be enough. And then we'll add a body. Maybe we'll center it, make it a header so it's big. Welcome to my page. All right. Closing tags. Okay, great. And last closing tag, we now have some valid HTML in here. So I've replaced this landing page. Let's see if that worked. And sure enough, it did. I get welcome to my page. So you now have a web server up and running. And that's it. That's how you launch an ECS instance. If I want to delete this, because it's a pay-as-you-go, I can delete it anytime just by checking this box and then choosing release. I could also change it to subscription. If I decide I want to keep it for a long time and I want to get a discount and I haven't purchased a reserved instance, then I could switch it to subscription. In this case, I'm just going to go ahead and delete it. I'll choose release now, next, okay, and that will delete my instance, and now it's gone. And that's it. Thank you for joining this class, and thank you for watching this demo, and I hope to see you in our future classes.